Hello, pre-algebra friends. We're going to talk about what a square root is and how we find it. So the first thing we're going to do is look at some areas of squares on this dot paper. And so I see figure 1 is right here. And I want to know what the area of the square is. So it's kind of, this one here just covers one box. So this square has an area of 1. And then I want to look at the side length, and it has a side length of just 1. So from there to there is 1. So that's not very exciting for the first one. Let's look at the second one. The second one, if I look at the area of this square, it has an area of 4. There are 4, 4 spaces that square takes up. So the area of that square is 4. And the side length is 1, 2. So take a minute, pause the video, and see if you can come up with the area and the side lengths for figures 3 and 4. So figure 3 has an area of 9 because there are 9 boxes in here. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the area is 9, and then the side length is 1, 2, 3. And then figure 4 has an area of 16. There's 4 by 4 here, so 16. And the side length is 1, 2, 3, 4. So then my question is, if you know the area, so if you knew this column right here, the area column, what could you do that would get you straight to the side length column? What could you do? What mathematically could you do to get from one to the other? And a lot of times my pre-algebra friends want to tell me, oh, well, I divide by 4. And I understand that because there's 4 sides to the square. But if I divide 1 by 4, that does not get me to 1. Or if I divide 4 by 4, that does not get me to 2. And so what we're really trying to do is figure out what I can do to get from the area to the side length. And so to determine that, we find what's called the square root. Now, a square root looks like a radical sign, so we call that the radical. And if I want to know, for example, the square root of 25, I'm trying to figure out what number or what value multiplied by itself gives you the value under the radical. So what do I mean by that? Let's look at some practice problems down here. So what I mean by that is here I've got the area of this square right here. So I'm saying that the area of this square is 64. In order to find the side length or the root of the square, so to find this side length, I'm going to find the square root of 64. And the square root of 64 is going to equal 8. And I know that because 8 times 8 equals 64. And I'm going to put my units on my answer. My unit is going to be centimeters. And your lengths are not squared. So it's just your area unit was squared, but your side length unit is just the measurement. So part B, I gave you the area of this square is 100. To find the side length, you would find the square root. So you would do the square root of 100, and that's going to be 10 inches. And I know that because 10 times 10 is equal to 100. So take a moment and try the next two on your own. Pause the video and check. All right, hopefully you've had an opportunity to work through those problems on your own. And you see that letter C is going to be 6 meters because 6 times 6 is 36. And letter D is going to be 7 because 7 times 7 is 49. So now let's look at the values in number 3. These look kind of similar, but I don't know what the square root of 72 is off the top of my head. I don't know any numbers that are going to allow me to find that without using a decimal. So I may have to use my calculator to do that. So when you go to your calculator, you're going to look for the radical sign on there. If you're using the calculator or the Calculate 84 app on your iPad, you should be able to see the square root button. Let me zoom in so we can see it. It's right there. See that little radical? It almost just looks like a little check. And to get that radical button, you're going to have to hit the second button. So you hit second, which is right here. And then you're going to hit this button down here, and it'll put on your screen up here a little radical sign. And then you're going to type in 72, and then you'll hit enter, and it will find that value for you. So when I enter the square root of 72 into my calculator, I'm going to get a number with a decimal on it. It's the first 3 digits are going to be 8.485, and there's some more after that. And we're going to ask you that you round your answer to the second decimal place, to the hundredths place. So that means I'm going to look at this third digit, and because this third digit is 5 or higher, it's going to round up our next digit. So we're going to round this to 8.49, and we're going to say that that's approximately the square root of 72 because we've done some rounding here. And then my units are going to be inches. If we try our next one, I'm going to find the side length, I'm going to take the square root of the area. So I'm going to square root 19, and I type that into my calculator, and I see I'm going to have some rounding to do. That's going to give me 4.358. So I look at this third digit, and I see that it's higher than a 5. It's 5 or higher, so I'm going to round up this second digit. So then the square root of 19 is going to be approximately 4.36, and then I'm going to put my units on my answer. So pause the video and see if you can square root the next 2 areas in order to find the side lengths. All right, hopefully you have the same answers that I do. I have approximately 11.49 meters for letter C. I had to round that digit, that third digit, or I had to look at the third digit to round the second digit. And I did not have to do any rounding with letter D though, and my answer is approximately 1.73 centimeters. So let's look at how the questions in number 2 and number 3 are different, because the ones in number 2 I was able to do in my head, and I was able to get nice, clean, whole numbers, so numbers without any decimal. And number 3, I wasn't. They were kind of crazy decimals that I had to round in my calculator. And the difference is, so a little vocab here, the values in number 2 are called rational values or rational numbers. And the values or the answers in number 3 are what we call irrational numbers. So we're going to look at those definitions a little bit more on our next page. What I want you to do here is fill out this chart on the right first. So I'll help you get started. So 1 squared means 1 times 1. So 1 times 1 is 1. In the next box, 2 times 2, or 2 squared means 2 times 2, and that is 4. So last one, and then I'll pause the video and let you work. 3 squared is 3 times 3, which is 9. So you pause the video and finish up the rest of your chart. All right, hopefully you've had the opportunity to fill out this chart, and you can kind of check your answers with what I have, so you can pause the video and check your answers. But what's special, oh man, I've got this crooked. These values that are in this shaded region all the way to the right, these are special numbers. We call these perfect squares. So these values, 1, 4, 9, 16, 25, 36, 49, etc. These numbers are perfect squares. And what that means is that when I square root a perfect square, I am going to get a rational number. So I'm going to write some notes in this box up here. If I square root a perfect square, so if the number underneath the radical is a perfect square, my answer will be rational. And then the opposite would be true of an irrational number. So if I square root a non-perfect square, then my answer is irrational. All right, we're going to have an opportunity to practice rational versus irrational with your class later today. I would like you to pause the video and look at numbers questions 5 and 6, and then I'll talk about the answer in just a moment. Oh, this is not meant to be right there. Don't worry about that. Answer 5 and 6. All right, hopefully you've had the opportunity to work on number 5 and 6. I disagree with Heidi in number 5. She says that her square doghouse has an area of 16 square feet. So to find the side length, you would square root 16, which is 4, because 4 times 4 is 16. And I also disagree with Adam in number 6, because, and you have to read very carefully, this says that he has a rectangular pen, which is not necessarily a square. So he could have a rectangular pen that had a square root of 100, and it doesn't have to be 10 by 10. It could be 25 by 4. It could be 50 by 2. There could be several different dimensions that would make a rectangle with an area of 100.